Hey guys, time for another lesson. The first lesson of Unit 2, Term 4, Laws of Logarithms. So the first thing I want you all to do is I want you to write down the log rules into your notebook. Unless you have a printer, you can just print this. This is something that I would hand out in class. So I have mine right here. My printer is weird, so it printed ginormous. But if you don't have a printer, just go ahead and take the moment, press pause, and write this entire thing in your notebook. The previous video that I posted kind of describes what a logarithm is. Essentially, a logarithm is another way that you can express an exponential. So it's basically saying what exponent does b, this base, need in order to equal x. That's what a logarithm is. So an example of that they showed in the previous video was if you had like log base 10 of 100 equals what? What this is basically saying is what exponent does 10 need, the base, in order to equal 100, which is the input. That's basically what a logarithm is. So when we're talking about logs, the common base or the general base of the log is going to be 10. That's the general base of log, okay? When we're dealing with natural log, which you'll see as ln, which makes no sense to me because natural log is nl, but whatever. The natural base of natural log is e. So that's something you guys want to have in your notes, that if the log doesn't have a base written, then the base of the log is 10. If the natural log doesn't have a base written there, then the natural base of natural log is e. Okay, so that's something really important that you want to have in your notes. Unless there's a base written otherwise. There could be a 5 here, that means the base is 5. But I'm saying if there is no base written, like this one, see how it says, let's find one. Let's find one where it's not written, and then I'll show you what I mean. So this one right here, there's no base written there, and it's a natural log. That tells you that that base is gonna be e. And if you're not sure what e is, that's okay. E is 2.71. So it's just like pi, it's 2.71 ... with like a million numbers after it, infinitely many numbers. But it's basically just a number that was derived to create an understanding of the golden ratio. And just like pi was a number to help people understand circles. So anyway, that's what E is. All right, so we're gonna go through the log rules really quickly. And to do so, I'm just gonna use my paper here, and I'm just gonna talk through each example and what it means. So basically, this first log rule says that, first of all, this is your base and this is your input. So if your input has two things multiplying each other, then you can separate each of these to make two different logs. So if you have multiple things multiplying each other in the input of the log, you can give each of those bases, well, it's the base of the input, so each of those items their own log, and you add them together. So log base b of m plus log base b of n, because m and n are multiplying here. Okay, so just like this example with the multiplication and the addition, the same rule applies if you have two things in the input being divided. You can give each of those items their own log. The top one is first minus the bottom one. So log of the top minus log of the bottom, if your input is two things being divided. Notice how that b carries over with it. So if the base is b here, or say the base is 5 here, it's gonna be a 5 here and it's a 5 here. If there's no base here, what do we know? Well, the basic base of log is 10. So if there's no base written, it's 10, and that would be 10, and that would be 10 as well when you expand it. This is called expanding logarithms, where we have multiple items in an input being multiplied or divided, and then we can expand them accordingly with addition and subtraction. I think when we do some examples, it'll make more sense. The next log rule we have here is the exponent rule. This exponent rule says if the input has an exponent, then the exponent can come down in front of the log and multiply. Okay, so if the input, so this is log base b of m. So m is the input. If the input has an exponent, the exponent can come down and multiply that log. So it can come down in front. And you're probably like, why the heck would I even need that? Well, guess what? You can't solve for an x value if it's in the exponent. So in order to be able to solve for that x value, you have to get that guy out of the exponent. And we haven't had a way to do that until now. Now we know with log, we can take that exponent and bring it down so it's no longer stuck in an exponent. So this is actually a huge deal for algebra and for logs. All right, the next rule here, these rules we're gonna get into in the next lesson more thoroughly, but I'm just gonna go through them very quickly. So basically this says, if you have a log base b of x, so base is b, and you take that log and you make this the exponent of the base of b. So the base is the same as the thing holding up the log. Do you see that? B here, then they can cancel, leaving only the input left over. Okay, you'll see some examples of that when we do the solving. So once again, the base of the log, if it's b, you raise the log from that exact same value, it'll cancel. So for example, if I have log of x, if there's no base written, what's that base? It's a 10. So I take 10, make this an exponent, 10 to the power of log of x, that will cancel, leaving only the input. Similarly, if I have natural log of x, we know that that base is e, right? If that is an exponent of e, the base here is e, this is e, those can cancel, leaving only the input left over. All right, the next one is if the base is the same as the input, it equals 1. If the base is the same as the input, it equals 1. And the reason we know that that's true is by the definition of a logarithm. A logarithm says, what exponent does this need? What exponent does this need in order to equal b? So what exponent does this need in order to equal itself? Well, an exponent of 1, because b to the power of 1 is b, right? So anything that has, any log or natural log that the base is the same as the input, it has to equal 1 because of the rules of logarithm, what it is. All right, the next rule says log base b of m equals log base b of n implies that m equals n. So basically, if you have a log of something equaling a log of something else and those bases are the same, you can just cancel those logs and those inputs are equal. Okay? The real reason why this one's true is because of this rule right here. But that's okay, we added it to the log rules page to make our life easier. The last rule is anytime your input equals 1 and you take the log of 1, it equals 0. Log of 1 equals 0, natural log of 1 equals 0. The reason being is that any number to the power of 0 is going to equal 1. Any number to the power of 0 is going to equal 1. Okay, so log base 5 of 1 equals 0. Log base 10 of 1 equals 0. Natural log base 20 of 1 equals 0. Natural log base e of 1 equals 0. Okay, so that is a just basic run through of all the log rules. Now we're going to utilize the log rules in the next video for the lesson, expanding and condensing.